person. See on camera, boys. It's watching you.
So best behaviour?
What's that?
Best behaviour then?
Oh, up to you.
I'm not
Do you
doing
want me to
anything
look
like
good?
sort of silky.
What's that?
I'm not doing anything like sort of silky.
Next lesson, going outside and doing outdoorsy stuff. So, anyone knows what outdoorsy thing? So, you need to bring let us know if there's any
I was going to bring my nice trackies and my so I still don't have it. I'll get it tomorrow. Oh, I won't be here tomorrow, so I'll get it.
Marcus here because we have another meeting.
What do you got to go?
The Winter Warrior thing?
Oh, okay. How long does it go for?
I don't know.
That's alright. Alright.
Right, thanks for this.
You can leave bags if you don't take it. Up to you.
Not bad, sir.
Good. You guys heard that shark song?
What?
That baby shark. Have you guys seen that thing? Nice, Mr. Cummins, looking fresh. What's going on? Fresh for the video?
Yeah.
On camera.
Oh, is it started?
Yeah, you're
Oh,
on.
is there a
Yeah, targeted.
Show me why that.
Yeah. Show me what it was.
What is that? Is that a phone?
Yeah, it's just an iPhone.
Oh. What's going on? Nice.
Do you guys have Winter Warrior? You guys doing that? Winter Warrior? Winter Warrior? There's a meeting.
It's not.
Just pay for it.
Yeah. $110 for 1 month. Each.
Not at this stage. Yeah, you're on camera, alright? So that'd be really good. If you're naughty, I've got evidence.
No swearing, Sean. Looked after you.
Yeah. Remember I spoke about transects? In quadrats? Have you had transects? Yeah, so we're doing stuff on that. And it leads into next week where we yeah. Which video? I'll look back. I've got like all the videos that we're putting up. Oh yeah, okay. Yeah.
Yeah, it's not there.
Easy peasy. Yeah. I'm trying. So, what are we doing?
Where is it?
I think there's a few.
Oh, we have to wait for this.
No, we'll just start. But yeah, there's a few with Winter Warrior. So what video do you need, Sean? Sean, which video? Antibiotics. It's the one like the cartoon one, there's bacteria, and then there's like a girl who's got muscle. Yeah, yeah, that one's short. Yeah. Maybe yesterday. Alright guys, we might get started. There's going to be some late comers because of Winter Warrior. So we'll leave the roll for just a little bit because I said that shouldn't be too long. Yeah, I've got a Winter Warrior meeting. Should be like 10 minutes there. Alright, so we're going to start off with 5 quick questions. So guys, the video thing is going, so if you don't want to be in the video, that's fine. But just let us know. Because I'll put you somewhere with some all good? Alright. There's no issue if you don't want to do it, that's fine. We don't need textbooks at the moment, we shouldn't need them. So just write 1, 2, 3, 4, 5 for your quick questions. As well as project this moving on. Okay, so you can use your notes. If you've got your books with you, you can use anything that you have. But we're just going to answer the 5 questions. So, right, 1, 2, 3, 4, 5. You don't need to write the actual question itself. You just need to write your answer. And I will put the whole PowerPoint onto the Google Classroom. So, if you're worried about you want to be able to revise it, it's got the answers on it as well. So, just worry at the moment about putting your answer down. Don't worry about writing the question because it's all there for you in the classroom. Okay, so question 1. Do antibiotics work on bacteria or viruses? So you just write bacteria or viruses, whatever your answer is. So to help you with that one, if you remember the example from the other day, how we spoke about the flu. Okay, so number 2, name 1 evidence for evolution. Already got it? Cool. So there's heaps, it can be any, it can be an example. Okay, number 3, the more similar an organism's DNA, the more likely it is they had either answer A for common or answer B is an uncommon ancestor. So A for common and B for uncommon. So the more similar the DNA, the more likely it is. Question 4. Why did some of Darwin's finches evolve to have bigger beaks and some evolve to have smaller beaks? And the answer is on the board. So I wrote all the answers out first and copy pasted them over to here, and then took the answers out. So don't look at this part. Alright, question 5 then. Good job. That was just a test actually to see if you guys were paying attention. Question 5. In stratigraphy, the study of geological layers, the top layer is typically newer or more recent, or older or less recent. So if you remember, stratigraphy was like, we looked at that big like cross section of the hill, and there was all these layers. Actually, that's our new question 4. So our new question 4 is going to be, what is a layer in you sure can? What is a layer in stratigraphy called? So what's a stratigraphical layer? It has a name.
No, answer it.
Oh wait,
I am asking, but I want you to write it rather than tell me and tell me at the end. So that's our new question 4. So you all passed the test, well done. Does anyone need a little bit more time? We'll go back to the question. Okay, we'll go to the answers. So for question 1, do antibiotics work on bacteria or viruses? Bacteria. And the example we used the other day was flu, and how you go to the doctor and you say, hey doc, I'm not feeling well, I think I've got the flu, can I get some antibiotics? And he says, nope. Because it doesn't work, exactly. Viruses aren't cells, so the way antibiotics work is, or some antibiotics work, is they come into the cell and they lyse it, which means basically bust it open. So it spills all its material out and basically the cell dies. Okay, so that doesn't work on viruses, it only works on bacteria. Question 2, name one evidence for evolution. So some examples are the fossil record, relative dating, biochemical evidence.
Comparative anatomy, comparative embryos.
What was that one?
Comparative anatomy, comparative embryos.
Cool. You understand? Biogeography is another good one. Anyone else have some?
Without using examples, though.
Yeah, what's the example?
Could you use the finches as the example for evolution? Or?
Yeah, for sure. You can definitely use the finches, but you have to be able to say, you can't just use the example and say Darwin's finches, because they'll be like, okay, why?
Yeah.
So as long as you can say why, 100%, and using an example is even better. It shows you know what you are talking about.
So was that geographical what was
Isolation,
it? Yeah.
finches, because they're on different islands.
Yeah.
And then certain things happen, certain selection pressures, so some of them have the big strong beaks. For the answer to question 4, this is why I put that in there on purpose. So our new question 4, what is a layer in stratigraphy called? A strata. So strata. Okay, so it's like a layer in the cake. And then question 5, in stratigraphy, the study of geological layers, the top layer is typically newer. So remember, down here, you've got, I'm not going to draw it, you've got your T-Rex down deeper, and then you've got your humans up higher, and then you've got your plastics and stuff like that even higher. So as you go down deeper, you're going back in time pretty much. So the deeper you go, typically the older it is, but remember that's not 100% always the case because of geological activity and mountains. Exactly. Some of the, I think it might be Himalayas, even though they're some of the tallest mountains in the world, they're some of the newest mountains. Is that correct, sir, or no?
Yeah.
Yeah. Cool. Right, so we're all good on that one? Right, so today, okay, so today we're going to be doing, we've got a transect. So you don't need to write this is just what we are doing. Can we though? Oh, you can write it if you want to, for sure.
Wait, are you talking about the stuff on the board, like the definitions and stuff?
Oh, sorry, no, I'm just talking about what I'm writing right now. This is just what we're going to be doing, but we will write this down if you want to. It's also going on for the master. So if you don't want to write it all out, because there is a little bit of writing in it, you don't have to, but if you want to maybe summarize it and do your notes so you can understand it better, that can be a good idea. So first of all, we're looking at transects, what they are, what we use them for. Then we're looking at quadrats, what they are, what we use them for, and how we use them with transects. And then we have an activity basically applying our new knowledge to a real life situation really. So who's heard of a transect before? Miles has? Yeah? What about quadrat? No? Laurie, kinda?
Quad, like 4.
Quad 4? Yeah? That's good. That's part of it for sure. So we'll start off with what is a transect. Can you guys see that okay? Turn the blinds down the front. Forward. Okay. So what is a transect? So the definition is a straight line or a narrow section through an object or natural feature or across the Earth's surface, along which observations are made or measurements are taken. So that's our actual definition. Easiest way to say it is, you guys can't really see this, so I'm going to draw it for you. So right here, colour happening. Got a lake, and then beside the lake, so this could be just down the road here. We've got some trees, some grass, some animals. Okay, so basically a transect line. You're already laughing at my drawing, I can tell. No, it doesn't, now you're lying. Alright, so we're going to take a straight line and just go bang like this. Okay? So we use the transect line to make measurements across the line that we've made. So results can be used to approximate the density in the area. So pretty much what this is saying is we want to know how many trees are in this area. Instead of going outside so you guys can see out there, there's a lot of trees, right? How long do you reckon it takes to count that? A couple of days, a couple of weeks, a couple of months? It's going to take a long time. So it's not really practical, is it? But if we want to know how many trees there are out there, we can draw a straight line straight out through the bush and walk along it, and we can survey the area along the line that we've determined and count. So even, for example, if we just counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 trees there, we can then calculate how much area we covered, and we can use that to make an approximation and like extrapolate it to say, because we use this one line, we know there's 20 trees. That was 10 meters out of 100 meters that we surveyed. So there's going to be 10 times 20 trees, there's 200 trees in this area. It's not going to be exact, but it's surprising how accurate these things actually are. Obviously you're going to do your averages and things like that to make your results as good as you can. So we use a transect to calculate the number of pebbles in the Pebble Creek in the playground. So that's something we're probably going to do as well. We're going to go out there and we're going to count the pebbles in the playground. We're not going to count all of them, are we? It'll take forever. So what we're going to do is we're going to use a transect line, we're going to draw our line. But then it's kind of like, well, what do you count? So that goes on to our next slide. Does anyone need that for notes still?
Can I just get the last one, please?
All good. So we'll just have another minute or so on that slide. So while we're still doing notes, can anyone think of an idea how we could make this transect line work better? How are we going to survey? We're doing the pebbles outside. How are we going to count them? Let's go easier. Let's start with the trees. How are we going to count the trees along the line? We've got to have some sort of rule, because it can't just be all the trees we can see. It could be, but that would be hard.
Every tree that's 5 meters away from us, within that.
So within 5 meters?
Yeah.
Yeah? Cool, that's a good idea. So that could work for something like that. Another idea is the quadrat. Okay, so quadrat, which is our next slide, it's pretty much a big square. Okay, so you're gonna have this square, and a lot of the time they have, are we good with this slide, guys?
Yep.
Nice, sweet. So a lot of the time, once again, that's kind of hard for you guys to see, but basically we're gonna have a square that looks like that. It might be made of wood, metal, PVC, doesn't really matter. So we've got this square, and what we do is we put this square at places along the line, and we count basically what's in the square. Okay, so that gives us more accuracy of what we're measuring. So we've got, that's called a quadrat. Okay, so like Laura said before, quad meaning 4. So it has 4 sides. It's square. So what is a quadrat? So it's a number of small areas of habitat, typically 1 square meter selected at random to act as samples for assessing the local distribution of plants or animals. So when it says typically 1 square meter, should probably say like an example is 1 square meter because while a meter is a good unit to use because we do hectares and things like that obviously, if we're doing something like Pebble Creek, 1 square meter, that's still a lot of pebbles to count. So it's a bit hard. So for every transect that we do and every quadrat that we make, we probably tailor the quadrat to suit the situation. Okay, so how do we use a quadrat? So we randomly place a quadrat along the transect line and measure what's inside. Okay, so why, does anyone know why we do it randomly? Yeah, to remove bias. Cool. So when I was in school, we did one on Whoopi Headland, and we were counting the shells. So there was 2 shells. I think they're called nudibranchs or something. Can't remember. Anyway, one was black and one was stripy. We did a transect line, and what could happen is you could have your square here, and you'd get 50, and you put it in the next spot, and you might get like 12. So if we were going out trying to count them and people were like, oh look, there's heaps there, and you put your quadrat square down and you count where there's heaps, and then you go to the next, do a couple more steps, and you're like, oh there's heaps there, let's count that. It's not going to give us accurate representation. So by having it random, it gives us our best possible outcome. So it's effectively, it's like good science, okay? So with good science, we try to remove the bias as best we can. Of course, there's always going to be bias, but we remove what we can to make it as accurate as we can. So what about if I said to you guys, all right, we're doing a transect and I'm going to get this quadrat and I'm going to throw it as far as I can. Would that work? No? Not really, because what about the ones that you feed? Like you're missing that whole area, you're pegging it as far as you can. It's random to an extent, but you're still applying this factor where you're throwing it as far as you can every time. Okay, so maybe if I can throw guaranteed 9 out of 10 times, I can throw this square 10 meters. You're missing that 10 meters. So it's not really accurate. So you want it to be random. One way they do it sometimes is they like turn around and you just like toss it over your shoulder. And wherever it lands, bring it back to the line and you count left or right. So that's something we're going to discuss because we're going to be using these transects and quadrats in the coming lessons. We've got like a bit of a big task. We're going to go out and basically do these for real. Okay? So an example of a quadrat, we place a quadrat along the transect line and count how many pebbles are in the quadrat. So if we did that, we're not doing a meter, are we? We're probably going to do something more like that big, because there's a lot. Okay, so that brings us to the task. You guys still have to talk and ask questions, it's alright. Yeah, it's real class, weird. Okay, so what I'm handing out is we're going to simulate going out of the classroom and counting a population.
Is this just like in class?
This one?
Yeah.
Yeah, sure. We're just going to do it today. So, first of all, we're all going to do it together. I'm going to put it up on the board. We'll do like an example. Then we're going to, you guys are going to do it on your own, and then we're going to like come back and check how we went. Does anyone not have a sheet? Might do the roll now, guys, and we'll just adjust it if they come back quickly. Oh, does anyone not have the Google Classroom yet and need the code? Yep. So do you want to just... Sorry. You can't see that. So that's the code. Let's write down 3FLXVY. So that's the Google Classroom code. And like Sean said before, she was like, oh, put that video up from the other day. If you guys have stuff like that you want to put on there, just ask, alright? I'll put this PowerPoint on and put that video up probably at lunchtime. Okay, so Alana's here, Aaron's away, Joseph, he's at
Yeah, Joe's here. Yeah.
Laurie's here, Lindsay's here, Nimrit's here, Daniel,
Yeah.
Miles here, Sean's here, James
Yeah.
here, Liam here, Reese,
Yeah.
Caitlin,
Yeah.
Kobe's at Winter Warrior, and Kate.
Wait, Jones is
Yeah.
that Winter Warriors, yeah?
Huh?
Oh, you're marking away still. Alright.
Oh, if they're not here, we'll mark them away, but when they come back, we'll mark them away.
Oh, it's Adam.
Sorry, Kane. Kane away?
Calm here.
Oh, sorry, man.
I think it's fine.
Dude, that was too much weight during 24 hours. Too much weight during the muscle on the system.
It's like 15 Ks or something, isn't it?
Yeah.
Yeah.
It's a long way.
It's $110.
It's a 5K run.
They should pay me $110 to run 15K.
That's a good effort.
It's a 4K walk with like a walk was in this in the park,
Really?
and then an 8 kilometers like scramble or whatever obstacle course.
You have to
We're going for
balance.
$110.
You don't run 15, no, like it's you push it through the.
Can you guys see that okay?
15Ks.
Okay, so this is your sheet. It's just up on the board pretty much. So I'm going to hand out, we'll use calculators and stuff in a minute. But first I'm going to do an example. Okay, so we're going to say we have a study area. You can write this down too. In your books, or it's really up to you where it's going to be more useful for you. But it's good to refer back to because we are going to be doing a fair bit of this stuff. So we've got a study area of okay, so this is 1 hectare, 10,000 meters squared, right?
You draw that, but
Yeah. So we've got 100 meters by 100 meters. We calculate what's in the middle. This times this equals that. So that's how many meters square we have. Alright, it's good so far. Okay, so we've got a 1 meter quadrat that we're going to use. So in that picture, quadrats I've used before, like PVC pipe, that white pipe. And they put them together. So they make them so they're kind of lightweight and easy to use. Because obviously you don't want something big and heavy. Because, so for example, if we go out as a class and we've got 10 quadrats we're going to use, you don't want them to be like 30 kilos each. That's going to be heaps heavy. That's going to be hard. If we've got to do a lot of walking with these things, we might be going up hills, over rocks. Yeah, how are we going to do that? So with a quadrat, you want it to be light and pretty easy to get around because with this sort of stuff, you're not always in somewhere where you can drive along and put it down. You might be going up all the route. Right? So it's hard. Okay, so we're going to use a 1 meter squared quadrat. Okay, so how many 1 meter squared quadrats are we going to have in our sample area? So I've got a square, it's 1 meter squared. We're in this area, we're going to have 10,000 of those little squares that we could possibly survey, right? Alright, so if we're going to do this, we don't want to just do 2 quadrats because that's not going to be a realistic sample that's going to give us like good data. If we even look out the window, if we were going 100 meters by 100 meters, there's clearly some changes. So throughout the window, we've got, so let's say about this much of it. So that's the building.
Minimum 2% to be statistically valid, and the closer you get to 5%, the more valid your results become.
What's that, Josie?
2% of your total area. So if you have 1 hectare, which is 10,000 square metres, what's 1% of that? 1,000 metres? Or is that 10%? So 1% is 100 square metres, so 200 square metres would be 300 out of that hectare. To be statistically valid.
Alright, so as if we look at that, that's our 10,000 meters squared, right? We don't want to just do, so where's it? Do the quadrats in place. So we don't want to do one square that might be about that big there, and one square that might be about that big there. That's not going to give us good information. It's not going to be reliable. It's not really going to tell us that much. It'll tell us what's in those two squares. As far as that environment as a whole, doesn't really tell us much. Okay? So what we want to do is we want to take a reasonable sample size. So like I said, minimum of 2%, and that's just to be considered valid. And obviously, the more you do, the better. Okay? But also in saying that, there's kind of a fine line, because if you say, alright, we're going to do 9,900 of these, there's only 100 squares that you're not doing. You're pretty much looking at the whole thing. And that's not the idea of a transect. The idea of a transect in quadrats is we're going to look at something like this. You might choose to go here to here. And you can do multiple transects in one area. You can do there to there, you can do there through there. You can do right across like that. Okay? And you might choose to do 20 along this line, 20 along there, 20 along there, basically to make up your 2% minimum. So just one. Oh, you probably don't really need to look at them. I can put the rest of the notes onto Google Classroom and you guys can use that. We're just demonstrating the task we're going to go through one together, and then you guys will do it yourself. Okay, so we're going to do an example. We're just going to write, we've done 10 quadrats. You guys still see this? So we've done 10 quadrats, and our results were, we were looking for kangaroos in quadrat 1, there was 5, 5, 4, 6, 6, 4, 5, 2, 8, 5 again. So what we're going to do is now we need to average our results. So I'm just going to come back up here. So to average our results, you guys know how we'd average this? Just the normal way, right? Add them all together. So when we add all those together, we get 50.
Sorry, is that how many? Because there wasn't each quadrant.
Yeah, so for our example, we're going to say there was kangaroos. We're going to say we spotted 5 in the first one, 5, 4, 6, 6, 4, 5, 2, 8, 5. What that equals, and add them all together. Yeah, so it equals 50. So 50 roos. Okay, and then so we've added them all together, and then we had 10 sample areas, so we're going to divide it by 10. And that equals 5. So that's our average. Okay? So then what we can do is basically, we say there was 5 roughly in our quadrat. So for this size, we're doing, so we're not, shouldn't change that really, it shouldn't be 1. We're going to use kangaroos, it should be, sorry to stuff this up, I'll just change that to 10 because 5 kangaroos aren't going to fit in a metre, are they? Alright. Okay, so then we calculate, we've got 5 in our 10 square metres, right? So now we need to know how many then approximately are in this whole area. Okay? So we've got 10,000 metres squared, 5 roos in 10 metres squared. So can anyone do the maths on that for me?
What math do you need more?
So this is our total sample area.
Yeah.
This is what we've sampled. We found there's 5 roos every 10 square metres.
Yeah.
Okay? Kangaroos. So there's 10 jumping kangaroos in every 10 square metres. So then we need to put this 10 square metres into our 10,000 times 5,000. So it's going to be
So it's going to be 5,000 roos.
5,000 roos in sample area. What's a difficulty we're going to have if we're doing something like kangaroos? They move around, alright? So then if we were doing this investigation, we'd have to make a comment on that, right? We might have counted the same kangaroo 4 times, so it might be skewing our results. But we can do things to minimise this, but it's more important at the moment that we're aware of it. So in our quadrats, we're going to, for the first few things, we're going to just be doing stuff. It's always going to be there. It's not going to move. Alright? So if you guys, does anyone need that on still? Yeah, that's right. Now also I've got that all written down, so I'll scan it and put it onto Google Classroom as well. Alright, so for those of us that are all done, we're going to look at this. We've got a square which is going to be green. We have an X which will be red. We'll use blue for our circle. Oh, there are triangles. Good point. We've got black for our triangles. Okay, so we're just looking at this one first of all. You guys are going to do that one and those ones too. So first of all, we're doing a transect, right? Let's give these things names, so it's a bit, let's call them something. What do we want green to be? Car. Okay, green's a car. Okay. James, what's X going to be? Anything. We've got a car. What about a person?
Red car.
Person? Miles, what's that going to be? Circle.
What should be?
A tree? Someone said tree? Now we've got a triangle. Who wants to do a triangle? Lindsay, do you want to do a triangle? Kangaroo? Cool, that's fine. That's alright. So now this area, we can say it's going to be whatever we want it to be. These can be magical L's, it doesn't matter. Okay? What we're looking at here, we're going to find out the population density. Okay? So we're going to draw a transect line. You guys don't have to draw it on your sheet yet because I've got rulers and stuff for you. But what I'm going to do is I'm going to pick to draw the transect line. You want to go up a little? That good? No, don't draw it yet. Just watch to start with, and then we can go back and draw it, and we'll do our own one in a minute. Okay? That's our transect. So we'll label that. So we're simulating transect line out in the field now. Alright, so this is our line through our ecosystem, our area, our, what we called before, our survey area. Okay, so this is our survey area. We're going to we want to place 10 quadrats, okay, and we've got to place them randomly, okay, so randomly can be left or right of the line, but we want to do one every 10 meters. So this is going to be 100 meters long. From there to there, every 10 meters. So this is our transect line.
Oh no, I just thought you were drawing the boxes on the line.
Oh, not yet. Okay. So we've determined that to get a good sample, we need to throw one in every 10 meters, alright? So, and it can be anywhere. It's going to be random. So what's a way we can make it random? Change people.
Just
Change people. Cool. Anyone got another idea?
randomly do it. Throw a ball, see where it lands.
Throw a ball. Alright, that's a good idea. So you could use a ball and use the ball to determine where you're going to put the square. Alright, what are you going to do if... What do you do if there's a big rock here?
You go over it.
Go around it. Yeah.
The ball's gonna bounce off.
So the ball bounces off it. Alright, so if there's ball, yeah, that's an issue because then that sort of changes that 10 meter section because you can't throw your ball, the ball won't land on it. So sometimes what they do is they could even get dice, and you could say, I've got 4-sided dice.
A4.
Hmm?
Like, do the A, B, C, D, F, G, A, 1, 2,
Yeah. Yeah, so you could figure out a way to make it completely random. Alright? Good. Yeah, exactly. You guys got other guys are like, oh yeah.
It could be hollow, then it could be
Think
hollow.
about that.
I don't know.
I don't know, maybe it's just,
It's burns.
maybe it's just size, maybe it's only 24
That's true.
Where's
I'm pretty sure 4-sided dice is impossible.
That's not.
If it was hollow, you're right. It could be.
Yeah.
Right, so
It's not the size of the inside.
for our sake, we're going to say it's random, and we've figured out our system where we basically put it in a grid pattern for every 10 meters. So we put 1 to 10 in a hat, and then we put left or right in a hat, and we shake it all up and we draw it out. And we've got our quadrats, and they go something like this. So these are pretty poorly drawn, guys. So it looks something like that, okay? Ours is going to look heaps better than that when we actually do it. But, so we're going to look through it, and we need to have a table, right? We need to record our results. So we're going to say we have 10 quadrats. 1, 2, 3, 4, 5, 6, 7, 8, 9.
It's gonna be a few people. That's about it.
It's going to be a few people. Yeah, so when we do it, we're going to split into 6 groups. Because that way we can cover more ground to do it more effectively. Right? So in quadrant 1, what do we have? One is one is at this is at the top, number 1. And this is number
A
10.
tree.
So we've got a circle which is a tree. So we have 1 tree.
Another tree.
Okay? So we have a tree. So you know tree.
Another
Number
tree.
2, what have we got? Tree again. Number 3, what have we got?
A car.
Okay, number 4. Hold on. What about this here? There's an X there.
Half person.
So it's person. So what do we do about things that are half in, half not?
Half person.
It doesn't matter what you do as long as you make the rule before you start and stick to it.
We count them as a
So you decide it before you start.
So this is our square.
You can say whatever you want, as long as you're consistent.
But it's just got to be for the same for everyone.
Correct. If it touches the train, if it
Okay.
touches the quadrat line, it's in.
So what are we doing? We have to make a rule, right? And the only way, alright, what's in though? What about, okay, so this one, more than half of it's in. This one, a tiny little bit of it's in. This one's only just nicking it. That one's nicking it from the inside, that one's nicking it from the outside. What are we gonna do? What's our rule?
Like if it's
Anything that touches the line is counted?
yeah.
Alright, so when we're doing ours, we need to specify that. So we'd say, with our transects, anything that touched the line, counted. Right? And that's a good way to do it because that makes it straightforward and easy, alright? Otherwise you got things on the border and if you're trying to do half in, half out, you're like, oh,
It was half
yeah.
congruence here.
Makes it hard, doesn't it? So,
Anything on or in the line?
Half a tree.
anything what?
On or in the line?
On or in the line, okay? So, up here we'll write our rule.
Yeah, can we copy what you got so far, sir?
You can if you want to, but you're gonna do it on your own for the next one too. So I want you guys to kind of, if you just watch for the moment, you can copy this after if you want to. So our rule is anything in or on the what's that, sorry? Yeah, so for inside each quadrant. Yeah. Okay, so we've got to go back. We've got that one that's touching. That one's good. We've got to add in an X, which is a person for number 3.
They've got a square in person.
The square. But if we go, yeah, that's a good point. So we'd say that's just touching, isn't it? So we'll put the square in too. So the square's a car. Okay, so now we're up to number 4. 1, 2, 3. That number 4.
Two people.
2 people. Number 5.
One person per tree.
Number 7. Number 8.
Two people.
Three people.
One tree.
Alright, so this one's good. In, what are we
That
calling?
Yeah.
That's out.
That's into.
Actually, it's kind of like
That's
On the
like
line.
the square, it's just on the.
It's just kind of doing that.
Alright, so let's say for argument's sake, this is our corner and that's just not touching. No part of it's touching, just for argument's sake. But our circle, we've got that, that one's in. So we've got 2 people and
Tree.
3.
I'll let you know.
What about number 8?
Nothing.
There's a rocket away.
Nothing. So do we say there's nothing or we just don't worry about number 8 or?
Empty space.
Yeah, so we should still, even if there's nothing, we should record that there was nothing there because that's still important. Number 9,
Another person.
goes
These
in the
are
tree.
forms in there.
It's two kangaroos.
Yeah, it's not sure about.
And the last one,
So this one's
2
got-
triangles.
Yeah.
So 2 kangaroos.
We've got a Jack Sparrow, Transformer,
So 2 kangaroos. So then what we would do is we'd go back and we'd put it together. We got 1, 2, 3, 4, 5 trees. 5. We've got 1, 2, 2 cars. Okay, about cars, trees done. People. 1, 2, 3, 4, 5, 6, 7 people. What else do we have to do? 2 kangaroos. We've got 2. So we're all set. So now we can go back, we can use that data, and we can calculate the area of our quadrat like we did before. We can calculate the area of the total area. Hmm? Yeah, so we've added these all together, right? We've worked out our area here and our area of the total. And then we can do our averages like we've done. We can do our quadrats, the area of it, the area of the total mass, and we can put that all together like we did in the last example, and we can find out what the total density of trees is. We can look at the total density of people. So this one's good because we're looking at 4 different things. So we're recording information for 4 things at once. Alright, so we can basically use that information to look at any of those things we choose to look at. So what I'm going to do is I'll rub that part out. And what I want you guys to do is look. You can do the first square if you want, but we'll probably be better looking at number 2 just so we're starting fresh. So I'll bring around rulers and you guys can determine, we're going to call this, how big do you want to make it? What's that area going to be? It's up to you guys. How many meters is it going to be from here to here?
30. 100.
Right, how many meters from there to there? 100? Okay, so we've got our 100 by 100. So what's our total area? 100 times 100 is?
You said 100 times 100 is 100.
So 100 times 100, like we did before. So our total area?
10,000.
And what's our units? Meters squared. Cool. So how big are we going to make our quadrats? Remember, guys, this is only a simulation or a demo. It's not. You don't have to say. You don't have to be too specific. So just pick a number. How big are our squares going to be? Well, kind of depends on how big you draw them, doesn't it? So if you draw a quadrat like that, but if your squares are this big, it's going to depend, isn't it? So I'll leave that up to you. You guys can decide. But probably.
Put them in a scale, won't you?
So, would that be more accurate since you got more like things to sample from?
Yeah. So obviously, the more stuff you include in your squares, the more accurate you're going to be because you're counting more. So if you did, the way to look at it is if you took your transect and you went like straight up here in a perfectly straight line, which that isn't, you're not really going to get a completely accurate view of what's going on, really. But then, if you went another transect on the same area like that, another one like that, you get a lot more accurate. So the more you do, the more accurate you'll be. Alright? On this demo, start with 1 for your first one, and then on your second one, you can do, maybe try 2, put them in different places. So I want you guys to pick your own size for your squares, but try and make it something workable. And then I want you to try and work out for yourself, and I'll walk around and help you work it out, what area is going to be in your quadrat square. So you know how we spoke about how you can take them around and put them down? You can also do something like Kobe said and throw the ball, and you could have a 10-meter quadrat, and you could peg it out with wooden pegs and put string around it.
Does it have to be on the line, or can they be like off the line out here?
Well, that's for you to decide. So if you're doing a transect, you might say it has to touch one side of the line. Or you might say it has to be 2 meters off the line. But whatever you do, you've got to keep it kind of similar, don't you?
Does it have to have like 10 of that little sample space?
That's up to you. It doesn't have to because it's your transect line. So you could have 10 of the little bits, or you could have 2 of the little bits. But if you do 2, you're going to get a much better result than if you do. Sorry, if you do 10, you're going to get a much better result than if you only do 2. Right, so who else wants a ruler? Anyone? So you're going to need to put a little table down the bottom of your page. Kind of. So, draw a line somewhere through. Draw a rule. Did quadrats have to be the same size, guys?
Yeah.
Yeah. Yep. Well, I guess they don't have to be, but if they are all the same size, you've got reliable results, don't you? If you're changing the size, you have less reliable results.
So it's like that's the one like you make it random yourself. Yeah, so like ideally we'd get like some sort of random system like a hat. Let's say you draw it out. Okay, for our first section, we're gonna have either left or right. First of all, you do the line, you might be on the line. So you get up the right or left. Draw it out. Right, your first one's gonna be left. So you're on the left. Then you might have this is 10 meters and another 1 meter.
Anybody need to calculate?
1 to 10. And then you draw out of the hat, and it's comes up the bank. So 8 meters up on the left. So that's what you draw. But because it's like hard to do in a small scale, you're not going to make this whole random system just to do it worksheet. So all you do is pick it randomly however you want. Like another way you could do it is you could do it without stop and you could just grab a quadrat and like throw it over your shoulder and that's where it goes. So just do it like elbow on the ball on the right. You still play? 100%. Yeah, you still play the Can't get it?
Okay, Lynn. So we got an average. So what's called this must be what's called 100,000. Sorry, 10,000 square meters, right?
Yeah.
Correct.
Okay. So that's what numbers.
And what size were your quadrats?
My quadrats were. Wait, you have to.
Still good.
Probably. But yeah, that's alright. But the idea is it's just a demonstration. It doesn't have to be exactly. It's just getting the information. Like how to use a transect and how to use a quadrat, and then when we go in the field, we can actually do it. And we'll be like, oh, that's so much easier. But like I was just saying before, you need to make it random. Yeah, exactly. So that's good. But if we make it random, we take out all the ones and throw it in the machine.
You can't exactly draw it.
No, exactly. Yeah, 100%. That's it. So it's just like, so what you get?
My calculations were within the entire area. There were 2,750. 1,000 large unidentified and 1,333 repeater. It doesn't live up to that. That's because that's the accurate representation. I'm going to all.
Good practice. Because we'll be doing this starting from home.
They're going to be the same.
What do we actually do? What do we actually do?
We're going to start with Pebble Creek, and we'll work on to some other things. That's all right.
I didn't like it.
That's okay. So what you do now is instead of doing 10, you write 9.
Oh, okay.
Yeah, so you don't have to do 10 quadrats every time. You can do 100 quadrats. It depends on the area. So you didn't mess up, you just did it differently, which is fine. Horses, people, cattle, good done. Good start. Alright, so now you need to draw a square.
Split, so what area? Do you know what area? What that is?
Yeah, bro, I'm not even.
What area that's on? Ideally, we still
Alright, just pack those up, keep them in your books, guys, and we'll do it.
And you've got to do that.
Start the next lesson, eh? Yeah. Yes, okay, I'll put all of it on the
Rain slips is the hardest thing you've ever done. Trust me, it's hard. You're too doing nothing, you sit there. Talk shit. I think it's fine. What? Whatever it's called.
I'll just go.
Roll set one.
I mean, I try. Brothers.
So you just want to get started here. Alright? Who made it all? We just leave it on Friday. Alright? Fridays. And then I went one of them. Was it?
So we'll make this back up.
If you get stuck in the stuff, you can come up with the stuff.
Wait.
That's the experiment.
Hey. Only like page marks. What I'll do is I'll scan
Without
it.
the extra chemical
On the
experiment, then, and you do that on its own, that's the control. If you add any other chemical to it, then that's your experiment.
It's so confusing. I know the word that I'm trying to think of. I said it at the start of the year. Yeah, I did, because I remember we were all like, you could experiment for a while, can't you? And you're like, yeah, that makes sense.
Think of it again and ask me again. Yes, Sean.
I don't know, I was just wondering, could I, you know how I got 18 out of 20 in my assessment? I was just wondering what could I have done to just get the pass?
Well, actually, nobody got 20. So you really only one mark off. So the only thing that was really missing is a little bit more depth in the use of the hydrogen proton pumps between the alkaline and slightly acidic water.
Is that for the vents?
Yeah,
Okay.
yeah. So just a little bit more depth in that area there.
Okay.
That was the only thing that was really missing. Everything else was fantastic, Sean.
Shouldn't be so bad, sir. I thought I got 19 out of 20, and then I figured out it was only 17. Because your circle connected to the 7, which made the 7 look like a 9.
I do apologise, Cody,
I
I hope you didn't draw that to your parents' attention, did you?
I drew the part where I realised that it was a 9, that it wasn't a 19, it was a 17, and I was like, because Jess was like, oh, you got 17, I was like, oh, yeah, I was hoping you'd notice it thought it might have been a 19.
Oh, thanks, John.
I'll turn that off.
Cool.
Oh, well.